the minimum or maximum values of a system of linear inequalities. Sometimes, we are asked to find the minimum or maximum values of a system of linear inequalities. This means finding one of the following values: a, the maximum x value of the system. In other words, we are asked to find the rightmost value of the solution set on the graph, b, the minimum x value of the system. In other words, we are asked to find the leftmost value of the solution set on the graph, c, the maximum y value of the system. In other words, we are asked to find the uppermost value of the solution set on the graph, d, the minimum y value of the system. In other words, we are asked to find the lowermost value of the solution set on the graph, e, a combination of two minimum or maximum coordinates, where possible. Obviously, the method used for this purpose consists of determining the solution zone by solving the given system of linear inequalities first, and eventually, solving analytically the corresponding system of linear equations to determine the intercept point of the graph with high precision, an action that is often impossible to do through the graphing method, as the solution pair may consist of rational numbers. For example, in the system of linear inequalities, we have the following shown on screen. We arrange first the two inequalities of the system to make them appear in the form y m x plus n, where represents one of the four inequality symbols. Thus, for the first inequality, we have the following shown on screen. Looking at this inequality from right to left yields, we have the following shown on screen. Hence, the solution set of this inequality alone includes all points previous the graph without those on the graph line. On the other hand, for the second inequality, we have the following shown on screen. Therefore, the solution set of this inequality alone includes all points under the graph including those on the graph line as well. The figure shows this system of linear inequalities solved graphically. We have the following shown on screen. From the graph, it is evident that the solution set has a minimum y value, which is at the lowest point of the solution zone. Hence, we can find the minimum y coordinate of the solution zone by looking at the intercept point of the two graphs. Since the graph method is not very helpful in finding a precise y coordinate of the intersection, we solve analytically the system of the corresponding linear equations to determine this point with high precision. Thus, we have the following shown on screen. We have the following shown on screen. Multiplying the first equation by -1 to eliminate y and then adding the two equations yields, we have the following shown on screen. Now, substituting this value found for x in any of the equations, for example in the second, we are able to find the y-coordinate of the intercept, which represents the minimum value of the solution set for the original system of inequalities. Thus, we have the following shown on screen. Therefore, the minimum value of the system of the inequalities, thus, we have the following shown on screen. Is y min equals 17 without including this point, as one of the inequalities, the first, does not include it. We say, the solution zone includes only values that have their y-coordinate more than 17. In addition, we can find the leftmost value of the solution set by considering the x value of the solution set. Thus, x equals 7 represents the minimum x value of the solution set, where again this value is not included, as the first inequality does not contain it. Example: calculate the maximum or minimum x minus and y minus values of the solution set in the system of linear inequalities. We have the following shown on screen. Solution. First, we have to express each inequality in the form y m x plus n to see whether we have to check for minimum or maximum values in the solution set. Thus, for the first inequality, we have the following shown on screen. And for the second inequality, we have the following shown on screen. Since the solution zone of the first inequality includes the zone the graph, including the line, while that of the second inequality includes the zone the graph, without the line, it is impossible to determine whether the solution zone contains a maximum or minimum without plotting the graphs. Hence, we refer to the figure for more detailed info. We have the following shown on screen. From the figure, it is clear that the solution set has a maximum point at the intercept of the two graph lines made of the uppermost y-coordinate and the rightmost x-coordinate. The graphing method is not very helpful in determining these two coordinates, so we have to solve the system of the corresponding linear equations analytically. Thus, we have the following shown on screen. Let's express the first equation as y equals 4x plus 1 and solve the second equation in terms of x by substituting y with 4x plus 1. Thus, we have the following shown on screen. As you see, this is a rational value, impossible to find directly in the graph. Hence, we say, x max equals -1 over 21. As for the maximum y value of the solution set, y max, we substitute in the first equation the value found for x, which yields, we have the following shown on screen. Thus, the maximum value of the solution zone is y max equals 17 over 21, as shown in the graph. That is all for lesson 10.4.2. To continue this tutorial, please watch 10.4.3. Systems of three linear inequalities. Thank you for watching. Make sure to like and subscribe to keep up to date with new videos. For more information, calculators, and tutorials, please visit www.icalculator.info.